Now we're going to look at some linear equations that involve fractions, which I know you love. And so what we're going to do here, since you love fractions so much, we're going to actually get rid of them. And so what's going on here is we have 4/5 times x minus 3 equals -2. And I'm going to go ahead and put those over 1 just to kind of look at this kind of leveled out here. And so look at all the denominators. And what we're going to do is find the LCD, the least common denominator between the three of them. Basically, you're looking for a number that 5 and 1 can divide evenly into. And so this one's pretty simple. It's actually just going to be 5. And so using our property of equality that we've done previously, what we're going to do is we're going to multiply both sides by 5. So we're going to multiply both sides by 5, and you can even put it over 1 if you want. Sometimes I like to do that just to kind of keep things on the level. And so the first part right here, when I multiply it, I have to distribute it. So I'm going to distribute it to both of these. And so I'm actually going to leave this as 5 times 4 for a moment. You could multiply it into 20 if you want, but later on in other units when we use this process, sometimes it's easier to not actually multiply it just yet. Then let's see, minus 5 times 3. That one, it's okay to multiply because your denominator is just a 1 to where it's not really even a fraction. So if you want to multiply that now, you can. So that would be 15 over 1 and then equals, and then we do the same thing here. -2 times 5 is -10 over 1. So the fractions with ones really aren't even fractions. I don't really need to write those. Like I said, I just kind of wanted to put everything on the same level. Now, I could have multiplied the 5 and the 4, but like I said, in later units, it's going to be easier to simplify because what's going to happen is what I introduce should reduce with my denominator, which in this case it does. I have a factor of 5 on top and bottom, and those are going to cancel each other out. And so then I'm just going to be left with that 4 times x, or just 4x right here, and then minus 15, and then equals -10. And then from here, we'll go ahead and solve this. At this point, this should look familiar from the previous video. So we'll go ahead and add 15 to both sides. And let's see, we're going to have 4x equals, so that cancels out, equals 5. And then we'll divide by 4, and we're going to have x equals 5 over 4. And we're just going to leave it like that. You don't need to write it as a mixed number. Mixed numbers can be useful at times, but for the most part, we're going to leave them as improper fractions. Okay, let's look at a couple others of these. So if you look at this next one, this time my LCD will be a little bit more complicated. It won't be too bad. So my denominators are 5, 3, and 1. So I'm looking for the smallest number that 5 and 3 can divide into evenly. And in this case, it's going to be a 15. So now what we're going to do, my property of equality, I can multiply both sides by 15 and preserve that equality. And that's what I'm going to do. And so whenever you multiply it by a 1, you really might as well just go ahead and do 15 times 1. So let's see, we're going to get 15 over 5x plus 15 over 3, and then equals, now this one, the denominator is a 1, so I might as well just multiply the 3 and the 15. That would give me 45 over 1. And so here I can reduce these. So this is the whole idea of what we're doing, is getting rid of the fractions. So 15 divided by 5, that'd be 3x. Then plus 15 divided by 3 is 5. And then equals 45 over 1. Once again, that's not even really a fraction. I can just go ahead and write it as 45. And then from here, we're just, like I said, this kind of looks like the previous ones that we've completed. So we go ahead and subtract by 5 on both sides. Then we're left with 3x equals 40. Then we'll divide by 3 on both sides. And we'll get x equals 40 over 3. And once again, we'll just leave it like that as an improper fraction. All right, a few more. So looking at our next one here, Our denominators are 4, 10, and 2. Okay, so I got to find a number that all of those would divide evenly into, and I believe it's going to be 20. Okay, and we've talked about in previous videos on how to find the LCD. Most of these should be fairly small to where it shouldn't be too difficult to figure out. Okay, so I'm going to multiply both sides by 20. All right, so here we go. And once again, all my numerators in this particular example, they're all ones, so that will make life pretty easy here. So let's see, we're going to get 20 over 4x plus 20 over 10 equals negative 20 over 2. Okay, so all these fractions should reduce quite nicely. So 20 over 4 would become 5x. 20 divided by 10 will be a positive 2. And then 20 divided by 2 is 10. And we do have that negative that was out front, so it's going to be a negative 10 right here. All right, time to solve this. So we'll start by subtracting by 2 on both sides. Then we're left with 5x equals negative 12. Next, we'll divide both sides by 5. And so we end up with x is equal to negative 12/5. And there we go. Okay, I have one left. One to go. Here we are. So looking at my denominators here, let's see, I have a 6 and a 3. So my LCD, that's pretty simple. It's just going to be a 6. And then the parts that aren't fractions, they still get multiplied by that LCD, so be careful. That's why a lot of times I'll go ahead and put them over 1 just to kind of remind myself. So I'm going to multiply everything by 6. So here, 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 and here. Okay, so let's see. This will become 6 over 6 times x minus 6 over 1. So there's the left side. Just multiplied the top numbers by 6 right there. Now on the right side, I'm going to leave this as 2 times 6. If you wanted to go ahead and multiply it, you could. But I'll kind of show you why I didn't in just a second. And then I will multiply the 2 and the 6 here because the denominator is 1, so I don't really have to worry about simplifying this. Now, the reason I didn't multiply the 6 and the 2 together yet is because I can simplify the 6 and the 3. Now, if I multiplied them, I'd have a 12, and the same thing, I could reduce it. But I'm kind of planning for the future. We're going to eventually deal with these again, but they're going to get a little bit more complex. And so sometimes it can just be helpful to not quite multiply them together until you've completed your simplification process. So let's go ahead and simplify these. So 6 divided by 6 is 1x, which the 1's understood. I don't really actually have to list it there. Then let's see, this will just become minus 6. And then here we're going to simplify this. So the 6 divided by 3 would become a 2, right? That would reduce to 2 over 1. And once my denominator is a 1, I really don't have a fraction anymore. But my numerator is going to be 2 times 2, which will give me that 4x right there. And then we have the minus 12. Okay, so now I have the variable appearing on both sides of my equation. So I'm going to go ahead and subtract an x from both sides to get started. And so we'll go ahead and cancel that out. And I'm left with negative 6 equals 3x minus 12. And then next, we'll go ahead and add 12 to both sides. And we're left with 6 equals 3x. And the last thing I need to do is divide by 3 on both sides, and I'm going to get 2 equals x. All right, so that's it. So this was solving linear equations with fractions involved.